Good day. This is Michael M. Ramos Jr., student of Master of Engineering, major in Computer Engineering. For this video, we will tackle about the data entry methods, specifically the polar coordinates. This is AutoCAD application number 7, based from the videos of Dr. Edwin R. Arboleda when it comes to computer aiding drafting and design. So from the previous videos of AutoCAD application 5 and number 6, we have here the absolute and also the relative coordinates. For AutoCAD application 7, we have here the polar coordinates. So when it comes to polar coordinates, we have here a command in which we will type at. We have here the distance, we have here the angle. So from the previous video, we have here at the change in x, comma, change in y-axis. So when it comes to the polar coordinates, we will use the specific distance or length of a specific line, for example, and we will indicate the specific angle of the elevation of our object, which is the line. So for example, we have here point 1 and point 2 in order to form a line. Point 1 and point 2 have a distance of 5 point. Okay? And from that point 1 to point 2, we have here an angle of 30 degrees. So this means that we have here a line point 1, point 2 elevated by 30 degrees with a length of 5. So to input it in our AutoCAD, so our origin for the point will be point 1 to point 2. So we have here at 5 less the, okay? So the less than is the angle itself, and we have here 30. So, if we will create a specific line pertaining to the angle or the direction, we have here the guidelines. So, when it comes to the guide, so if we want to create a straight line from this point to the right, so we will include the length of the line, okay? So, at length, we have here the angle 0. So, to form a line. So, if we want to elevate it with 1 degree up to 89 degrees, so we should indicate the length of the line, then angle the degree. So this is 45. So if we want a vertical straight line, so we must indicate the length of the line, then angle 90 degrees to have a vertical going upward. Okay? If we want going downward, so we have here 270 degrees. If we want a line from this point to the left, so we will indicate the angle 180. So if we want a line elevated to this left part, so we must indicate the angle starting from 91 degrees up to 179 degrees. And based from this part, okay, if we want a specific line elevated downward, okay, elevated downward, so it's incorrect term. So if we want a line pertaining to this part of line, so we must indicate the angle 181 up to 269. So we have here these angles as our guide if we want to create a certain line based on the format of their orientation from point 1 to point 2. So let's try to apply it in our AutoCAD. So for our polar coordinates, let's apply this at distance angle in this example. So this example was used for the absolute coordinates of our previous video, which is the video number 5. Then also it was applied also in video number 6 for the relative coordinates. So for our sample, when it comes to polar coordinates, so let's do this example figure for, okay? So for point 1 and point 2, we have here a distance or length of 3. So for example, so we have here the previous drawings, okay, from video 5 and video 5, video 6. So for this video, so let's create a point or a line in this area. So let's type L for line. So once we've indicated the line, so let's try to create a point from the x-axis 1 and y-axis 20, for example. Okay, so I think let's undo. Let's type again line, then let's try 1 comma 15. Okay, so it's closely or nearer from the previous figures created on video number 6. So we have here the starting point at 1 comma 15. Okay, so to create a line from point 1 to point 2, so let's try to input the distance and also the angle from point 1 to point 2. So the distance must be inputted, which is at, so we have here the distance of 3 comma, then the angle is 0 degrees because our line is going to the right. So based from the previous diagram, if it is going to the right, so we must indicate 0 degree. So 3 comma 0. Okay, so let's try if it is okay if we input 360. So let's undo. So at 3 comma 360. Okay, so if we will apply 360, so I think it is wrong because I've inputted 3 comma 360. So it must be, so let's undo, at 3 angle 360. Okay, so at 3 angle 360 and also at 3 angle 0 is the same. Now, from point 2 to point 3, we have here a length of 1.4142 with an angle of 45 degrees. So let's type it at 1.4142 and we have here angle 45. Okay, so based on this line, it was or it is the same. Okay, so next we have here point 3 to point 4. So point 3 to point 4 has a length of 2. So let's type at 2. Then angle. Then the angle from point 3 to point 4 is going upward. So it would be 90 degrees. So let's type 90. Okay, so it is just the same. Okay, so next one. So let's try to type P4 to P5. So we have here a length of 4. So at 4 angle. So the angle from point 4 to point 5 is, we have here, it is 0. But if it is going to the left, so let's input 180 degree. Enter. And to close the line, so we have here 0.5 to 0.1. We have here 3. So the length to be indicated must be at 3, comma. So the angle is vertical. So we have here 90. But if it is going down, so let's input it as 270 degrees. Okay. So let's try. So at 3, comma 270 and then, okay, I think I've inputted a wrong input. So it must be angle, not comma. So at 3, angle 270. So based from this, it is closed or automatically it matches the point A. Let's press enter or escape to cancel. And we have here the same figure as the first one, which is from the video 5 and also from the video 6. Okay? So by applying polar coordinates, it also the same with the absolute and also the relative coordinates. Okay? So the first example figure is satisfied. So the application of our polar coordinates is good. Now let's apply the application of polar coordinates in our exercise number 1. Okay. So for our exercise number 1, let's see. Okay. So for our exercise number 1, we have here a figure of letter H. So let's try to apply it in this or in our AutoCAD. So let's try type L for line. Then let's type a specific coordinate. So we have here, for example, 7, comma 15. I think undo L 15, comma 15. Oh, I think it's wrong. Let's try to type this list. So the starting point of our line is from x is 1, y is 8, 18. Okay, so I think let's try to type L7 comma 18. Oh, sorry. L7 comma 18. Okay, so I think it's okay if we are not aligned from this point. So let's try to create H. Okay, so for H we have here A, B, C, D, E, F, G, H, I, J, K, L. And as you can see, we can create it easily because all of the angles will be based on 0, 90, 180, and also 270. Okay, the lengths will be satisfied to be 1 and 3. So let's start in creating point A to point B. So we have here at, so point A to point B has a distance of 1, comma, the angle would be 0 because it's going to the right. So it's not comma but angle 0. Okay, so next one, we have here point B to point C. Point B to point C is 1. So we have here at 1 angle. So it's going up. So let's indicate 90 degrees. Next one, point C to point D. We have here at 1 angle. So it's going to the right. So let's indicate angle 0. Okay. Point D to point F. So it is 1, the length. And it is going down. So let's indicate the angle 270. So at 1 angle 270. Okay. Next one. E to F. Point E to point F has a distance of 1. So let's indicate at 1. So it's going to the right. So let's indicate the angle 0. Next one. Point F to point G. Point F to point G has a distance of 1 plus 1 plus 1, which is equals to 3. Okay. And it's going up and it's vertical. So automatically we have here at 3 angle 90 degrees. Next one. We have here G to point H. Point G to point H has a distance of 1. So it is going to the left. So our angle would be at 1 angle 180. Then hit enter. So next one, we have here H to I. H to I has a distance of at 1 angle. It is going down. So we have here 270 degrees. Okay, based on our angle direction. Next one, point I to point J. So it has a distance of 1. And I to J is going to the left. So automatically our angle would be 180. Next one, we have here point J to point K. Point J to point K has a distance of 1. And we have here going up. So the angle would be vertically up. So it was equivalent to at 1 angle 90. So for point K to point L, we have here distance of 1. Then we have here the angle from point K to point L, which is going to the left. So it is horizontal. So automatically it is 180 because it is going to the left. 180. And for the last one, we have here point L to point A. So the distance from L to A is 3. Then we have here a vertical line. So it is a vertical line going down. So automatically the angle to be used is 270 degrees. So let's indicate at 3 angle 270. So once we press enter, automatically it will hit the point A. Press enter or escape to finish the figure. So as you can see, the example number 1 or figure number 1 is identical to what is in our PowerPoint and also identical to what we have done in figure or video number 5 and figure number or video number 6. Okay. So another application of our polar coordinate is for our figure number 2. So figure number 2 has a slanting line. So we have here an angle of 45 degrees. And some of the parts of this figure 2 has an unknown angle. So let's try to solve it later. Okay. So let's start with indicating the point A in this part, which is we have here the figure number 2. So let's try to type line. And for our line, let's hit enter. So automatically, once we type line, so let's indicate our starting point to be 12, comma, let's indicate 20. Okay, so let's say that this is the starting point of our drawing. So for example, we have here point A. Okay, point A to point B, we have here a distance of 1 and the angle is 0 because it is horizontal line. Okay, so let's type at 1 angle 0. So this is our point A, and this would be the point B. For point B to point C, so it has also a distance of 1. And if it is vertical, so it's going up, so automatically our angle would be, we have here at 1, angle 90. Okay. So next, we have here point C to point D. As you can see, our point B to point C has here 1 value. Point C to point D has also a value of 1 when it comes to the vertical distance, or horizontal distance rather. So if it will form here a imaginary one, or imaginary line which is 1, and we have here the height of B to C which is equals to 1, we can form a specific triangle. And as you can see, if we have here an opposite side and we have here the adjacent side, so this is the hypotenuse side, so we could apply the Pythagorean Theorem. So we have here a squared plus b squared, and the sum of a squared plus b squared must be square root. Okay? So we must square root the sum of the square of a and b. So we have here square root of a squared plus b squared. Okay, so based on this, to get the specific line from point C to point D, so we must go to 1 squared plus 1 squared, and then we will square it. So 1 squared plus 1 squared, so we have here 1 plus 1, we have here 2. So let's compute for the square root of 2. So let's use our browser. So let's type square root of 2. And based from this, we have here 1.41421 356,237. So let's try to copy this one. So we have here, we could say the exact square root of 2. So let's apply it in our AutoCAD. So let's type at, we have here, paste. So 1.43421356237 angle. Okay. So based on our diagram, we have here point C to point D. So if this is, if we have here a triangle with the same lengths, so automatically this would be 90. Okay. And once the opposite and adjacent have the same sides, automatically the angles of both of this part would be the same. So if this is 90, this would be 90 over 2. So we have here 45 and also 45. If we will go back to our direction, so if we have here this specific point of line, we have here 270 going down. And if we have here a line forming at this point, so this is an exact 45 degrees. So we have here 270 plus 45, we will get 315. So at this point, we will indicate angle 315 degrees. Okay? So as you can see, it matches, okay, the previous one. Okay? So let's go back to our diagram. Okay? So for that, we must compute the hypotenuse side, and also we could get the specific angle. So at this case, we can easily get the angle because both sides are equal. So now, we have here point D to point E. Point D to point E has a side or length of 1. And if it is going down, so automatically the angle that to be used would be 270. So I have here at 1 angle, sorry, not comma, angle 270. Okay. So next, we have here angle E or point E to point F. So we have here a distance of 2. Then the angle would be 0 because it is going to the right. So we have here at 2 angle 0. Okay. So the same. So we have here point F to point G. So point F to point G has a certain angle which is 45 degrees. But the point or the point of the line F and G is unknown. So we have here the basis, okay? The basis in which the horizontal, okay, distance from point F to point G is 2. And the vertical distance from point F to point G is 1 plus 1, which is equals to 2. So let's apply the Pythagorean Theorem. So we have here 2 squared plus 2 squared. So based from that, we have here 2 squared, which is 4, and another 2 squared is equals to 4. So for 4 plus 4, we have here square root of 8. So let's try to indicate in our calculator. So I will use Google for faster processing. So I have your square root of 8. So square root of 8 is equivalent to 2.82842712475. So let's copy it and paste in our CAD. So let's try to type at, and then let's paste the square root of 8. So automatically, the value is pasted. Okay. and then indicate angle. So we have here the angle based on our PPT presentation, which is 45 degrees. So let's type angle 45 degrees. So automatically we have here the same line. Okay. So from that, we have here a line which is 2.82842712475. So we have here point G to point H. So point G to point H is 1.5. Okay, 1.5 going up. So we will indicate at 1.5 angle 90 vertical. Okay, next one. We have here point H to point T. Excuse me for that. So point H to point I rather. We have here a vertical or horizontal distance rather of 2. So the vertical distance is not indicated. So if this is horizontal and it is going to the left, automatically we will declare at 2 angle 180 degrees. Okay. Okay, so it is straight. Okay. So next one, we have here point I to point J. Point I to point J has a value of 1. And if it is vertical going up, so automatically it would be 90. So at 1 angle 90. Okay. So next one. So from point I to point J, we will have point J to point K. So point J to point K has a specific distance of 1. So this one is going to the left. So automatically our angle would be 180 degrees. So let's try to input at 1 angle 180. Okay. So from this one, we have here point K to point L. Okay, point K to point L has a vertical or horizontal distance of 2, and we have here a vertical distance of 1. Okay, so point K to point L, the length is unknown. Okay, so to find out the distance of point K to point L, so let's apply the Pythagorean Theorem. So we have here a squared plus b squared, so we have here 2 squared plus 1 squared. So we will get 4 plus 1, which is equal to square root of 5. So let's try to input square root of 5. Square root of 5. So we have here 2.236679775. So let's try to copy it in our AutoCAD. So let's try to type at, then paste the value of our line, then angle. So for the angle, so we have here an unknown part. Okay, so based from the angle, okay, so we have here the point of reference in K. So in order to have a line from point K to point L, so we must know the angle of this point. Okay, so to get this point, so let's apply the trigonometric identities. So when it comes to trigonometric identities, even though we have here the value of our hypotenuse, okay, because it is the largest or the longest line or longest side based from our opposite and adjacent. So in our trigonometric identities, we have here the sine, cosine, and tangent. So in sine, we have here so. In cosine, we have here ka. And when it comes to tangent, we have here toa. Okay? So for this point, I will use only the adjacent and also the opposite. And adjacent opposite is applicable in this tangent. So for sine, we have here opposite over hypotenuse. In cosine, we have here adjacent over hypotenuse. And when it comes to toa, we have here opposite over adjacent. So at this point, we have here the point K, and this angle must be computed. So for this one, we must apply our formula when it comes to tangent, which is the opposite over adjacent. Okay? So to formally compute the specific angle, so we must apply the tangent or we must apply the arctan. Okay? So arctan is used in order to calculate the angle of a specific side. Okay? Or angle within the triangle. So let's try to type arctan. Then let's try to indicate the values of our opposite and adjacent. So we have here opposite, which is equals to 1. And we have here adjacent, which is equals to 2. So arctan 1 over 2. So once we indicated that, so we have here 0.3926082 rad. Okay? So we have here a value which is in a form of rad. So let's try to see if there is alternative way to get the whole value of arctan 1 over 2. Okay? Arctan 1, 2 in degrees. Okay? So, arctan 1 over 2 in degrees is 22.5 degrees. Okay? So, some say 22.5 degrees. So, let's try to have arctan calculator, for example. Mm, arctan 1 over 2 in degrees. We have here 26.56. Okay? So, this is the exact amount or exact value of our arctan 1 over 2. So, the earlier one is not exact. We have here, we get 25 point something. So, here arctan 1 over 2, we have here 26.56 or 565051 degrees. So, let's try to copy this. And let's paste it in our CAD. So, let's see if it will have the same answer. But, okay, once we hit or click enter, we have here this specific line. So, as you can see, it is not the same as what in our figure. Okay? So, to tell you, in order to have this line K to L, so if the angle at this portion, so let's try to see here in our angle direction. So, if we have here a point and we want to create a specific line going there, so this is the angle we've get. So, to get the exact angle, so the angle we've got or the resulting angle must be added to 180 degrees. So, let's try to undo this part. Okay? So, from our calculator, so we have here 26.565512 plus 180. So, we will get 206.5650512. So, let's try to copy it in our calculator or in our, AutoCAD. So, we have here so we have here 2.2360679.775. So, the earlier length of our point K to point L, 2360679.775. Angle, we have here 206.5650512. So, we have here this line. So, based on our diagram, it is the same. Okay, point L to point M. So, let's move forward. We have here a line or figure which is equivalent to 1. So, if it is going to the left, automatically the angle would be at 1 angle 180. And click enter. So, for the final point, okay, so we have here point M to point A. Point M to point A has a distance of 1.5 plus 1, which is equivalent to 2.5. So, based from the line, M to A is going down. So, vertical line going down. So, automatically, the angle to be used is 270. So, for this one, we should indicate at 2.5 angle 270. So, automatically, we close the line at exact point A. Okay? So, if we will round off a specific angle or specific line, there is a possibility that the line or the points are not accurate. So, for a tip, so let's try to indicate the specific value. So, if it is 8 digit or with 8 decimals, 10 decimals, so it is preferable to use. So, based on our diagram, so this is from video 7, this is from video 6, and this is from video 5. And all of them are the same to what are in our example. Okay? So, for the last figure, we have here figure 3, which is the arrow. So, let's apply the polar coordinates. Okay? So, let's try to type L for our line. So, specify first point of our line. So, let's try to indicate 15, comma 15. I think it is wrong. So let's undo. Let's try to indicate L, 20, comma 20. Okay, so we have here this diagram at this point, point 20, comma 20. So let's apply point A to point B, distance of 2, angle is 0 because it is going to the right. At 2, angle 0. Okay, so we have here the base point of our arrow figure. Point B to point C, we have here distance of 3 going up, so automatically it would be 90 degrees. So at 3, angle 90. Next one, we have here point C to point D. Point C to point D has a distance of 1, so the angle is 0 because it is going to the right. So we have here at 1, angle 0. Okay, now when it comes to this point, point C, so we have here unknown angle, okay, and from this we have here the vertical, okay, the vertical alignment or the vertical side of point D to point A, which is 2, and the horizontal side of point D to point A, which is equivalent also to 2. So let's solve for this length of point D to point E. So based from the previous example, if we have here point 2 to point 2, so let's apply the Pythagorean Theorem. Square root of 2 squared plus 2 squared. Okay, so we will get 2 squared is 4 plus 2 squared is 4. So we have here square root of 8. So let's type here square root of 8. So square root of 8 is equals to 2.82842712.475. Okay, so we could use this for an exact number or exact length of our line, or we could use this specific value given on the other side. So we know that if we will try to have this figure, so this is just the mirror of this one. Okay, so they are the same. Okay, so let's apply only 8 point or 2.8264. Okay, so let's try to type at 2.8264. Okay, 8264. Then the angle for this one is 45. But based on our angle of direction, so if this is the point and we have here a line going, okay, going up to the left, okay, going northwest, so we have here this 45 degrees. So 90 plus 45, so we will get 135. So we have here angle 135. Okay. Now, next, so let's apply point E to point F. So we have here 2.8264, the same length, and we have here angle 45. Okay? So if this is angle 45 and also this is angle 45 as the adjacent one, so we have here a imaginary line for 180. So 180 plus 45, so we will get 225. So based on our angle direction, so this is a 45 degrees also. So we have here 225. So let's apply 2 point at 2.8264 angle 225. Okay, so click enter. So we have here the same as the point D to point E. Now, from point F to point G, we have here a distance of 1. The angle is 0 because it is horizontal going to the right. So we have here at 1, angle 0. And to close the line, we could type C, or let's try to apply the length and also the angle of point G to point A. So we have here the length of 3. Okay, at 3, angle. So we have here angle point G to point A. So it is going down vertically. So we have here angle 270 degrees. So if we will hit enter or escape, as you can see, we hit the specific point of point A to point G, or point G to point A. If we will compare this arrow from the previous one, it is the same. So these are the samples we've used from video number 5. Okay, video number 6, and also from video number 7. So based from these, all of our application, starting from the absolute coordinates to our relative coordinates and also to our polar coordinates, are the same. Different application, different methods, both are with the same results and output. Okay, so I hope we've learned a lot and you applied what I have learned when it comes to the application of relative coordinates. So if you love and like this video, hit the like button and also subscribe to my channel. So in my channel, where we apply what we've learned from the academe. Thank you so much. Have a great day and stay safe.